So this is the presentation that I gave at Synergy. The attendance this morning is about the same as it was. They gave me an 8:30 time slot, and on the last day, and I was up against I think Ingmar was doing a session on PBS. My colleague Al was doing a session on HDX 3D Pro at SpaceX, and I'm like, okay, cool. So I got the redheaded stepchild, Moonshot, that nobody really wants to talk about, up against all of these heavy hitters. So.
No, that's kidding.
I love you saying.
I give you support.
I love you saying.
I'm supporting you.
So it is a controversial topic. I'm not going to lie, and the reason is because it's going back a little bit to the way that we were doing things before, in a sense, and it doesn't have virtualization concepts apply. Still data center hosted desktops, so I'll get into that. There is a picture that I had taken during the keynote, during the big reveal. I don't remember who was Neil. I think Neil was kind enough to take that one. So we're all in the industry, so you guys probably know who I work for. Entysys in Northern California. Our Southern California counterpart is Agile 360. I think everybody pretty much understands why we do desktop virtualization, hosted desktops and apps in the data center, and all of the reasons behind that. So I won't talk much to that, but just to say that most of those reasons apply for Moonshot as well, instead of having a hypervisor. So, all right, so this is the basic Citrix Consulting Services design handbook for how you would build a XenDesktop type of solution. I'm pretty sure everybody's familiar with these concepts, but on the left you have your user layer. This is the delivery groups and the presentation of the applications and desktops. And you have the access layer, so the NetScalers, the storefront. The control layer across the bottom for the delivery controllers, director, studio, Active Directory, license server, SQL, so on and so forth. The piece that Moonshot applies to, all this is the same for Moonshot. The piece that Moonshot applies to is the top right corner where we talk about the resource layer. So in your traditional XenDesktop model, these are all the different ways that you can deploy your solution, FlexCast as the marketing guys like to call it. So pooled desktop catalog, personal catalog, hosted apps catalog, shared desktop catalog, Xen client, remote PC access. And then over there is what you would actually put the solution on. A little bit different for remote PC access, but you get the point. The PCs are over there in the corner. Okay? So, little disclaimer, I don't work for HP, neither am I paid by HP to deliver any of these sessions. It's just a new technology, and I like talking about stuff that's new. It's the same reason why I love the HDX 3D Pro stuff, the Atlantis computing storage optimization stuff, because it's new, it's emerging, it's different than what we've been doing. I also don't work for Citrix, so I don't get paid when they sell licenses for Moonshot. But the way that HP, we're an HP reseller, that's our main hardware infrastructure business that we would go through. And we do a ton of business with HP storage. 3PAR, we were the top reseller in Northern California last year for 3PAR, or HP storage as a whole. But before 3PAR came along, HP really didn't have a compelling story for storage. They had the MSAs, they had the P2000, they had store, whatever they call it, the P4000, which was a left-hand appliance. And when 3PAR came along, it was enterprise class, high scale, high efficiency, and we've just done a ton of business with HP 3PAR as a storage. So even the HP guys is kind of, this whole topic is a conflict of interest because there's not as much storage involved in a Moonshot oriented solution. And so the HP storage guys are like, whoa, what does this mean, right? What about my big SAN that I'm going to lose out on? So anyways, this is the way we normally attack a desktop virtualization solution with either blades or rack mount servers, some form of SAN or local storage, and then the hypervisor on the top and the virtual machines, right? And these are what HP calls industry standard servers. So they fit across pretty much all x86 applications and platforms. Moonshot's different. So this is a slide that they had from, or some marketing stuff that they had from the first generation of Moonshot. And there's a wider range of things that they're targeting for this. Basically, this is software-defined hardware. Instead of basically having a wide breadth and depth of what applications and what workloads can fit on this, Moonshot is all about targeting a specific workload. It's a widget for a workload, as they like to say. So if you have a workload that is web content, either static or dynamic web content, instead of having 1,000 or 2,000 virtual machines on a VMware infrastructure behind load balancers that consume SAN resources and everything else, you might consider either their Atom or their Avaton-based processors have all the storage local, and it's more of a Google Compute scale-out type of approach. No hypervising involved. Okay, so the chassis that they're shipping today is what they call a 1500 chassis, and it has 45 individual serviceable hot plug cartridges. So I've done a demo a couple times, and we've recorded it, where you pull the chassis out of the rack, you take the lid off, and immediately it'll spin up like a jet plane. Like, louder than servers powering on when you take the lid off, and the reason is because of cooling, heat dissipation, and things like that with the top off. But all of the cartridges inside, while the system is running, you can pop them out and do service on the cartridges, put them back in, grab the new MAC addresses off the cartridges, and rebuild those particular systems. So again, 1500 chassis, 45 cartridges. I imagine in the future there might be, a different chassis that has different form factor for cartridges, but this is what is available today. For customer POCs that we've been doing, they have what they call a power-on kit, which is a PONK, as we like to abbreviate it, which is kind of fun to say. That basically is a desktop form factor, so small form factor desktop, and it holds 2 of these cartridges. It has all the same interface from a manageability perspective, so the same CLI and all that kind of stuff that the chassis and the switch has. It just only has 2 cartridges. So we're able to just, say, okay, customer, you have an existing VMware environment, that's where we'll put your DDCs and stuff, and then we'll just use these for the actual desktops. All right, so with Moonshot for XenDesktop, here's basically how this right quadrant looks from the overall design. You have pooled desktop catalogs and personal desktop catalogs. No hosted app catalog, shared desktop catalogs, and client or remote PC access. So people that are in the know that that means not XenApp, right? You're not going to do XenApp on this particular model. They do have the Avaton cartridge, which is what they call the M300, which is an 8-core Avaton processor with 32 gigs of RAM. So it's a little bit bigger for more of a server workload. They just haven't done all of the marketing and all of the back-end dev type of work to see how good of a fit that is for a XenApp workload. So today this is intended for XenDesktop, so VDI, client OS, that type of thing. And pooled desktop catalogs use provisioning services. Personal desktop catalogs would just be operating system and applications installed on the actual cartridge. Okay, so the one that I held up and the one that I have in the back of my rental car is an M700 cartridge. So this is what they call a 4-to-1. On each cartridge, again there's 45 of them in the chassis, you have 4 nodes. Okay? There's no sharing of resources between these nodes. They're dedicated compute, storage, and memory. Okay? On the front-ish side of the cartridge, you have 4 heat sinks, one for each APU. This is what AMD calls an APU accelerated processor unit, which combines x86 CPU and GPU capabilities on the same system on a chip architecture. So instead of having discrete graphics with a PCI bus, it's baked into the chip. What that also means is that it's not high-end graphics, but it's the equivalent of integrated graphics if you have a laptop or a desktop without a discrete graphics card today. Okay? So this is a 4-to-1. If you flip that cartridge over, which I brought the cartridge in my session, on the back is the 4 DIMMs for memory. Okay, so there's no sharing of memory, no sharing of CPU. The piece that's shared, obviously, is this connector as it goes down into the chassis, and then inside the chassis are the switches, which I'll get into in a bit. Okay, so that's that, and then it's not on this visual, but right here actually, in this visual, and then this connector here is a mezzanine SSD, ISSD as they call it, or internal SSD. And that's basically a SanDisk SSD. The original that I have is 128 gigs that they carve 4 ways, so it works out to 32 gigs per node. Again, there's no sharing for that SSD. It's individual blocks within the SSD, carved 4 ways. The new one that they just started shipping about 2 weeks ago is a 64 gig model. It's, again, 256 carved 4 ways, so it's 64 per node. And they weren't really having a conversation around persistent hosted desktops up until the 64 gig release, because 32 gigs is enough for your OS and applications, and that's about it. You can get your OS and stuff installed just enough to get it pulled into PBS, but then you wouldn't have much more for persistent desktop. So in terms of the stats, it's a quad-core, lowering proc, so they're more of your mobile proc, which means that there's better heat dissipation and lower energy consumption. So this could also be a play if a customer is really concerned about what their data center footprint is going to be for the kilowatt hour perspective. So they're quad-core, 1.5 gigahertz. The Radeon 8400 is what they call it for the integrated graphics. It basically has 512 dedicated memory and then shared memory as well. And then 8 gigs of memory on the back, dual NICs, and then, yeah, like I mentioned, 32 or 64 gig SSD. So in terms of the proc, because that's everybody's concern that I've talked to, wow, that looks like a really low-end proc, right? The way that I correlate this is, if you're doing 2 vCPUs and 4 gigs of RAM for your VDI hosted desktop today, this is probably a good fit. And the reason is because those CPUs are dedicated resources and not shared, and it gives you a little bit of room for expansion into the future, because we all know the application work set is going to change, right? So this is a rigid model. It's not like virtualization where you're able to tune up and tune down resource allocation. So you really have to know your user base that you're trying to target with this, and then say, okay, for these 800 users, this is going to be a good fit. For these other users over here, we need to do either XenApp or some higher-end graphics. So the way that HP looks at it, and I've talked to them about where this fits in the spread, in the spectrum from least to heaviest in terms of user intensity and what people are willing to pay for a system, you have XenApp session hosted on the far spectrum. This is task workers, lockdown experience, things like that. Then you move into a pooled VDI, where there may be application compatibility issues or some reason why you can't do a lockdown XenApp experience, but you need a client OS. And then you have more of a dedicated PC, a dedicated VM, user installed apps, things like that. And then on the far spectrum, you start getting into vGPU, VMs, enable VMs for a little bit higher graphics, but not high-end graphics. And then the far spectrum, of course, is Blade PCs. When you look at this, this particular solution that they have available, it really wedges into that middle of the spectrum. It's not intended for XenApp, and it's not intended for the high-end Blade PCs. HP and others still have the Blade PC business in that market, and we have a lot of customers that is the model that they use, mainly oil and gas when they have billions of dollars to spend. But this basically wedges into that middle spectrum because it's not a high end and it's not a low end. Okay. The other thing that I like to point out is people have a hard time with the cost for this type of solution because they're not building VDI solutions the way that this is a fit today, right? The way that this is a fit today is if you're doing a quad core, or more respectively, If you have a 3 gigahertz processor, you do 2 vCPUs, 8 gigs of RAM, 500 IOPS for SSD type of storage. And the most important thing is you'd be doing reservations on those vCPUs, right? Because this is not shared from a compute perspective, there's not contention for resources. So if you wanted to truly see that, you'd have to do 2 vCPUs with reservations so that the users always get dedicated threads. And that's why this is such a hard conversation, is because the whole reason why you do virtualization is for overcommit, right? And in the marketplace, everybody's been going hog wild with number of vCPUs to vCPUs because they're usually trying to impress their CFO and talk about how low they can get the cost. But as Helga's session pointed out, you can optimize for 2 things. You can optimize for performance, you can optimize for cost. And they're always in conflict with each other. So that's a little spiel on that. This is what the chassis looks like. So the cartridge is over here. Down the middle is 2, again, hot serviceable switches. These are 180 gig switches. The math basically works out to, each cartridge has 4 nodes. There's 45 in a chassis, so 3 rows of 15. And so you do the math on that, it's 180. Since each node has 2 1 gigabit networking ports, that works out to 2 180 gig switches, okay? So they're redundantly connected, one to the left side, one to the right side. And then on the back, those internal switches go out to redundantly connected uplinks that go up to the top of rack switch, okay? So what they're shipping with today is that guy up there, which is just freaking badass. I love this thing. It has 4 40 gig QSFP ports. I don't think you're going to have any concern about bandwidth at that point. Most of our customers are comfortable with 10 gig to the chassis and then 40 gig to the PVS servers or 40 gig to the infrastructure as a backplane. I've not seen somebody say, yeah, I'm going to deploy a whole new 40 gig infrastructure just for this Moonshot thing. So what they have is a Mellanox 40 gig QSFP to a 10 gig SFP adapter that you can buy. They also have, in case you're really interested, what they call an octopus splitter, which basically takes the 40 gig QSFP, splits it out to 4 10 gig SFPs, and then if you need 40 gigs, you can take all 4 of those and then Ether channel, or whatever the term is for HP for Ether channel, IRF group them together, and then you would have 40 gig to the chassis. Okay? The power supplies, there's 3 or 4 of them on the back, I don't remember exactly. But the entire chassis can run off of one of them. So the other power supplies are just N+1, and then they do generate power because in the event of a failover, there needs to be power coming from others. So they will pull power from your PDUs, but just something to know about that.
The whole chassis can run off one?
Yeah. These cartridges are rated. These cartridges are rated for 45 watt each.
Okay.
Yeah. And they're either 1200 or 1500 watt power supplies. So very energy efficient cartridges. I've not made the pitch to a customer. This is why you do this over virtualization yet, because I don't have enough hard and fast data that says based on this kilowatt hour dollar amount, this is what your energy savings would be. But I do know that for the first generation cartridge, which is the atom-based one, HP switched off some of their integrity web hosts in favor of this. They ended up replacing 8 racks for www.hp.com. Used to be 8 racks of integrity BCS is what they call them. And they consolidated that down to less than half of a rack on the atom-based Moonshot. And their energy savings alone paid back for the cost of the Moonshot in 6 months. That was their ROI. Yeah. Obviously, it was their product, so they got it, at cost. But based on the MSRP or the list price, their ROI for that switchover from BCS integrity to the Moonshot was 6 months. What's up, Carl?
Back in the old days, when we had slide rulers, 45 times 45 is 2025. So you'd have to have more than a 1200.
Cool. Thanks for challenging me on that. I'll get an answer for you if you're really that interested.
I would suspect it's either n plus
45
2
is-
or n plus 1. So you either need 3 or need 2, and then the others are redundant, or load balanced.
I haven't done a failure with a fully populated chassis to pull out all of them but one. But I have, with a partially populated chassis, plugged just one of them on and powered them up, and there is no issue. So it's probably the fully populated at peak, when they're all drawing peak, that there would be 2 or 3 of these that are pulling. So, thanks for challenging me, Carl. Keep it lively.
Well, as young as you are, you probably did do math when you went to school. So.
We just skipped right to calculus. I missed all that algebra stuff. All right, so this is the basic setup for a very basic environment. This would all be scaled out if you're going to do it in larger scale. But this is a basic proof of concept setup with the pooled concept in mind. So provisioning services is the image delivery layer here. Most of the content that's out there is about PVS for the delivery, and that's because the 64 gig SSDs just started shipping about 2 weeks ago. So there hasn't been as much talk about dedicated personal desktops. But if you look at like a hoster, some of the things that they have to go through from a licensing perspective is no shared resources and things like that. And so they're looking at this being an option for that, since each customer would be able to get dedicated cartridges. I don't know how that works for the chassis, but we'll see.
Does the PVS licensing model still support this? Because they had physical PVS for a while, and then they pulled back from it.
So XenDesktop Enterprise or higher is what's required. And XenDesktop Enterprise covers stream to physical. So educational customers that are doing computer labs with PVS to stream to physical, they have to buy XenDesktop Enterprise. Same thing here. The only difference is then you're using XenDesktop as the broker to connect into those versus having it bare metal. Okay. So the ILO or management network would connect to the CM, as they call it. This is, for those that are familiar with HP, this is not your traditional ILO. This is not web-based. It doesn't have a console for the actual server or the cartridges. This is more of a CLI interface to configure the switches, to configure the actual chassis itself, to get the MAC addresses off of it. And for those that know PBS, the only thing that's unique about a piece of hardware is the MAC address. So the most important thing is making sure that that plumbing is in place, and then being able to grab the MAC address so you can plug it into PBS. So the ILO, so that being said, this is the tricky part. When I got my system back in December, before they had GA'd it, I was discovering, trying to figure this whole thing out. I was like, okay, where's the ILO? Where do I get the console of the actual cartridge? And you have to do the entire thing dark. It's kind of like being blindfolded. You have to make sure that when you Pixie boot, that it's able to connect to your infrastructure, pull down the image, and you basically get what ILO calls the non-interactive mode, I think is what they call it, which is basically everything until the operating system starts booting, right? That's what you're able to get when you're doing this start. So when you SSH in or when you console in, you can get to what they call a virtual serial port that will show you BIOS, show you post, show you all that kind of stuff. And then as soon as it starts to boot, that's when it's going to cut out and you're not going to get any visual, because you can't get visual if you're in an SSH session. Okay? So then the domain and PDS network would be on the same, and then connected over to a basic cluster that has AD, DNS, DHCP, file server, print, PBS, XenDesktop, all your normal infrastructure management plumbing for XenDesktop. And then up in the top corner I put WDS, which is temporary. If you're going to have this in a production environment, I'd recommend you keep that around for a while. And that's really just to rebuild your gold image. Hands off my gold image. The interesting thing is that this works with the original OS deployment, which I would recommend for persistent as well, actually works with WDS, MDT, SCCM, Altiris if you have it. It's basically just a Pixie boot and then install the OS. So During that process, of course, at some point when the operating system is laid down, you'll be able to figure out what the IP is, and then as it's going through that process, then you can RDP into it, and then you're no longer in the dark, right? It's just that initial process when the OS is being laid down that you're not going to see that visual. And so what I recommend is that you have, a test VM on this hypervisor virtualized environment, that you actually do a test, do a couple run-throughs of a WDS deployment to that virtual machine, so you can see if it fails or if it goes through that process. If it goes through that process, then you should be all set. The guides that HP produced for this are actually very conclusive. They walk you through the entire process, including the WDS setup, Windows deployment services. No load, because I switched it off. Cool. All right, so there's two things that I'm going to run through here, basic setup for the chassis and then basic setup for XenDesktop with the chassis. So the first step is to connect and configure the chassis. All of these bit.ly links go out to the different guides on HP's site. If anybody's been an HP customer for any period of time, you know that their documentation portal is absolutely abysmal. Trying to find exactly the guide that you're looking for is just very difficult on HP's site. They've been around for so long, it's just terrible that they have they're almost as bad as Citrix. So connect and configure the chassis, and then you're going to configure the switch. They already have a template, basically a config file, that if you're using VLAN 101, you just replace the VLAN that they have in the basic switch config with 101. If you're using 201 or whatever, you just go in there and change those configs. And then when you connect and configure the chassis, configure the switch, you can just copy paste that config, drop it on there, connect your uplinks, and you'll be connected to your network. It's really that simple. It's like a basic stack of switches, really basic config. Okay? Install XenDesktop, this is the controller. Install PBS. Install WDS, which is just temporary. Optionally, if you're wanting to get fancy, you can integrate WDS with MDT or System Center Config Manager, and then install your operating system using the OSD deployment process. That's actually what I did the first time I deployed, because I already had my MDT script set up for installing the operating system, installing the applications, installing the VDA, installing the target device software for PBS. And so I was able to just take their WIM image that they wanted to use that has the drivers already injected, and then plug that into my MDT process, and then it deployed the OS, and all of that bit was already taken care of. And then the most important thing is test DHCP, PBS, or the WDS network connectivity using the virtual serial port. You need to make sure that the actual, the first node on the first cartridge can actually boot. All right, so then this is the setup that's specific to XenDesktop with PBS. First is to build the master image. Second is to install the agents. Third is to capture your master image using the PBS streaming wizard. And then to place the image in shared mode, execute some PowerShell scripts, which are really cool. They did a really good job developing those. And then create and deploy desktop snaps. So again, all of these guides are bit.ly down at the bottom. And all of these slides are already posted to my blog if you want to check them out. All right, so build a master image. HP has basically a kit that they have available on their site that has the unattended installation files and has the drivers for the Broadcom NICs that are on the actual cartridges. So HP supplied drivers. You'll use your ISO image from your volume license service center, and then merge those together using a process that's all documented in the guide. It's a little bit of rocket science, but they have it well documented. And then the applications get merged in there as well. So the first step, or step 1A, is to load the WDS server with the OS image files, the drivers and apps. Second step is to image the node with the OS and drivers from the WDS server. So this is basically taking that image that you created, booting up the first node in the first cartridge. It'll install the operating system using WDS to the internal SSD on the cartridge. And then test deployment using a virtual machine, as the Moonshot CLI doesn't provide much visual interaction. In other words, unless you like being blindfolded in a dark room, do it in a VM first to make sure it works in a VM. If it works in a VM, it should work on the cartridge. Okay, next step is to install the agents, which you can do through an RDP session at this point. You just need to get the IP address off the first cartridge, and then you can RDP into it, update the image on the ISSD with the drivers, apps, XenDesktop VDA, PBS target device software, all that. Yeah, once the OS is loaded, the IP address of the node can be obtained using the virtual serial port. So you go into SSH, you connect to the first node on the first cartridge, the one that you deployed to, you do an I command, and it gives you the IP address, and then you can go to RDP into it. All right, next step is very familiar to all of us. This is capturing the image for PBS. If you're not using PBS and you're using the 64 gig options, you know, these steps obviously changed. But you know, the first go-to-market strategy that they had was PBS, so you get some of that, you know, shared image management stuff that people like. All right, so the golden image is captured to the PBS server. And then you do that through connecting through RDP, convert the ISSD image to PBS vdisk using the imaging wizard. Again, all of this is covered in the guides. And then use RDP to boot the first node and the first cartridge to the vdisk, and then connect to make sure you can connect over the stream. And then convert it to shared image mode, change the write cache to local hard disk drive. HP actually has a model that you can subscribe to that actually saves a bit of cost by basically pulling those mezzanine ISSDs off and using RAM on each of the nodes for your write cache. I think RAM with overflow to disk is a little bit safer approach because 8 gigs by the time you get your OS and applications in there, there's not enough left for just dedicated RAM for write cache. But it does work, and it is very fast. All right, so then the PowerShell scripts. HP developed these. These are to install on your PBS server. And when you go through the PowerShell scripts, it will ask you a couple different questions, like, okay, what's the IP address of the management port? What's your username and password? It'll go out and connect, and then it'll run a script that does a show inventory that will return all of the cartridge numbers and all of the MAC addresses for the cartridge numbers, and give you the output for the text file that then gets imported using the PBS import wizard to actually pull these guys in. So this is what it looks like. Slot numbers are right here. So 4, 7, 10, 13. The way that they number them is kind of interesting. If you have a fully populated chassis, it doesn't really matter much. But they actually start in the top left corner of the chassis is 1. Then it's 2, 3. The next one over is 4. Then it's 5, 6. So it goes 1, 2, 3, 4, 5, 6. So if you have all of your cartridges for like a 15 cartridge initial install, in the top, it's actually going to be 1, 4, 7, 10. It add 3 every time all the way up. Kind of interesting. I think they should have done it the way that we read, which is 1, 2, 3, 4 across the top and then more like that, but whatever.
So should memory.
What's that?
So should memory.
So should memory. Okay, so then when that's done, it's exported the MAC list for NIC1 to that CSV file, which then you can use to import into PBS using that wizard that we're all very familiar with. All right, next thing, of course, because we didn't use the XenDesktop setup wizard or the streamed VM setup wizard, we have to actually create the catalog in the delivery group in XenDesktop. So the type is going to be physical hardware with provisioning services for the image delivery. When you go through that wizard, it will basically say, okay, I'm not going to do any hypervisor connector for this to do power management, but I am going to then connect to the PBS server to connect to that collection and then import all of these guys in. At that point, you can boot all of your nodes in the chassis with the newly created OS image streamed by PBS, and all of the writes at that point will go to the ISSDs that are on each of the cartridges. And Yeah, and then you can actually connect in through XenDesktop for the broker, and you're on your way. They're working on a couple things to make this whole process better. It's solid today. You know, you could do this entire thing as I described, and you have PBS for image delivery. You've got XenDesktop to broker things in. The piece that they're working on is power management. So right now the way that it works is you just keep all the nodes on all the time, or basically plan your own capacity and power up cartridges, power down the cartridges. But the thing that they need to do for that whole idea that they have of conserving energy is to actually intelligently power up and down the cartridges based on the usage within XenDesktop. So they're working on a connector. It's going to look very similar to the hypervisor connectors, like we have the Azure connect or the AWS connector and Cloud Platform connector, and we have Hyper-V, Zen Server, and vSphere. So it'll be another connector that has all of the APIs to talk directly to the onboard administrators, and then power up and power down the cartridges. So that's futures, some stuff that they're working on.
So we built directly right into the studio?
Yeah.
They're talking about?
In the future, yeah. They're working on getting that connector built just like they have for AWS and stuff. Anybody that follows my blog, I put some YouTube videos up quite some time ago that basically show HGX 3D Pro on Moonshot, because it does have a GPU on every chip. You can do DirectX and OpenGL.
What's your blog again?
It's itvce.com. And then these YouTube videos, you can just hit them directly. If you just do a YouTube search for Moonshot HGX 3D Pro, I'm the only one that has any videos up there. Not that I'm proud of that or anything. And immediately after I put these up, I was immediately told by Citrix, you need to put a disclaimer on there, because my testing was done independent of HP and Citrix, right here. Okay? And the reason was because when I put those up there, it wasn't supported. And I pressured them enough to actually get them to have something more than supported by Synergy. So, right here, this is the important part. Citrix and HP recommend the use of the standard VDA, which they have optimized for the API calls for AMD. So you do get some acceleration. For example, if you do a Windows Media Player video with the standard VDA, it's going to look like garbage. If you put the hotfix on there that optimizes it for the AMD APU, and then you do a Windows Media Player stream, it'll actually do the decoding of the Windows Media Player using the APIs to the APU. So they do have that hotfix that makes the standard VDA better, but as we know, the standard VDA doesn't support higher levels of OpenGL or higher levels of DirectX, and so you have to use HGX 3D Pro for that. So the Red Engine one is probably my favorite because everybody likes seeing those types of visualizations these days. And I did these all in real world scenarios. This is not, Sean and Benny style. I didn't put as much science behind it, but it's basically from my home internet connection through a NetScaler gateway that's a VPX across 30 to 40 milliseconds of latency to our demo center, and then ran each of these demos and captured them just using like Snagit on my machine. So I don't have the DVI offload encoder thing that Benny and Sean have. Anyways. So if you want to check those out, it's pretty cool, and I was able to get them to say supported with limitations. So basically what that means is Citrix has some bugs. Go figure, right? And they wanted to make sure that those bugs were documented in the CTX article before they said, yeah, go for it, Mr. Customer. Do HGX 3D Pro with this, and not really have an idea of what you're getting into. So Tony Sanchez, which is a guy within Citrix, used to be actually responsible for all the Hyper-V and System Center stuff, the reference architectures and stuff that Citrix put out. He's moved over to the HP Alliances team, so this is his baby. He did a session as well, Sin 317, and in his session he talked about some of those limitations and promised on recording that they will have a CTX article within the next couple weeks. So it's coming, which honestly this is one of the more exciting pieces of this technology. So how many users can I fit on a box? Age-old question, right? You log in VSI, you do some real-world tests, you try to figure out during your pilot, okay, where are my breaking points and how am I figuring out like what my stress is on this particular environment? That's the age-old sizing question. We use tools like logging VSI, we use monitoring tools to grab the data and extrapolate, okay, how much scale can I push this thing to? How much cost can I lower? All that normal stuff, right? That's not the scenario with this. This is more about properly classifying your users, which you do using like Lakeside software and the Coolware Labs, or if you have an existing VDI environment, which we have seen as the primary target for this, somebody that already knows the challenges that come with a shared infrastructure, that knows the challenges with not being able to properly monitor storage latency and all of that, then we would talk to them and see, okay, how do you classify your users for VDI today, and which one of these would be a good fit for Moonshot moving forward? It's not a good fit for everyone. It's not one-size-fits-all solution. That's not what this is. So properly classifying your users, so you have a blue fish, an orange fish, or a purple fish. And then once you properly classify your users, figure out which of those users would be a good fit for this. My personal opinion, and this is not HP saying this is not Citrix saying this, if you have less than 500 users that fit this particular mold, don't even bother. That's my personal opinion. The reason is because you're going to have a different architecture and a different support process for those users than you would for the other community. So unless you can get a couple of these chassis, so it makes it worth checking out a different architecture, my opinion is don't even bother. If you were trying to deploy rapidly, go from 1,000 users to 5,000 users, this is brilliant because you just drop in additional chassis, you grab the MAC addresses off, you drop those into PBS, and you have rapid expansion capabilities. But if you're doing less than a couple chassis, checking this architecture out really, it's not a good fit in my opinion. Because you're going to need users on the low end for XenApp, you're going to need users on the high end, and this is not one size fits all. So if you do that, your fish might end up looking like this. You might have too big of a fish and too small of a bowl. If you try to cram a user that should have a Blade PC into a VM that doesn't have graphics capabilities, same thing, right? If the user's not a good fit and you try to cram them into the solution, the user is going to want back into their big bowl. They're going to want back to their desktop, they're going to become a desktop hugger, or if you already have a VDI environment and that was a better fit for them than this is, they're going to say, okay, let me be back on that previous VDI platform. So it's really about making sure that your users are a good fit for this. It's not about seeing how many users can we fit on the box. That hard math is already done. Your users either fit into this mold or they don't, right? And if your users fit, they're going to fit. All right? So many know that the login VSI workload has changed dramatically from 3 to 4. The new medium is more like the old heavy. So if you've looked at any reference architectures from Cisco or HP or Dell or any of those, it's very important to note what version of heavy they were using, what version of medium they were using. Was it 3.7, was it 4? Because this medium workload lapses about 48 minutes, has 23 applications. It's a significant workload, or 23 different application instances, okay? And that's just like a snippet of it, a couple different things throughout here. And I have a demonstration, but I'd rather show you the login VSI results. So again, this is not about how many users can I fit on a box, it's how much workload am I putting on this thing, and are my users going to be a good fit. So I use the login VSI medium workload. Again, my testing was done independent of HP and Citrix. So this is a sample, but it's not something you can go to a customer and say, according to this reference architecture, this is the workload, blah, blah, blah. And what I found was that over the 48-minute period of flaps, the average CPU on that quad-core 1.5 gigahertz was about 11%. There were peaks and valleys, of course, throughout that period of time, but the average was 11%. So at face value, you may say a quad-core 1.5 gigahertz really isn't that much, but realistically, based on the logging VSI workload and the fact that it's able to do offload to the GPU, it's able to deliver a significantly better type of averages. And again, because this is dedicated, if that's the experience for one user, that's going to be the experience for the next user, for the next user, for the next user. All right. The next was committed bytes in use, which was actually surprising to me. 8 gig system, and it averaged 38%. I tried to correlate that to a virtual machine, and I was having a hard time because I'm like, well, in a virtual machine, we usually, our go-to is usually like 2 BCPs and 4 gigs of RAM, so that's using 38% of 8 gigs. Like, what gives? And what I basically was, reminding myself is that when more RAM is there, more RAM will be used. The more RAM that you have available, the more RAM that's going to be cached from an NTFS file system and everything else. And what that's going to relate to is faster load times of applications and a better overall user experience. So that was actually a pretty cool value. What that also told me is that there is no way that I would be recommending cache to RAM. It would be really cool to have a blazing fast PBS with cache to RAM scenario, but your user experience would be impacted because having available RAM is a really cool thing.
Windows should automatically back off that cache if other stuff needs it.
Yeah,
So
if other stuff needs it.
cache, it'll automatically flush it.
Yeah, I agree. All right, and then everybody wonders about network, right? Because the 2 1 gig NICs per VM, that's pretty much what we do today, right? Either E1000 or well, Hyper-V is a different story because they have that legacy NIC and all that nonsense. But the average was 237 kilobits per second, and that includes the PBS traffic in there, and then the peak was 12 megabits per second. And I tried to do the math and make sure that my algebra was right, and I think I worked out that the theoretical maximum of 1 gig NIC is 125 megabytes per second.
Yeah, you're correct.
I could be off. But I know there's overhead and things like that, so you're never going to get that. But, what that showed me was that even at peak, it never goes above 10% for a particular node. And then again, 180 gig switches internally, 320 gigs of potential traffic to your upstream switches. Nobody's going to do that, but you could have if you wanted to. And then this transfers per second, the average was 15 IOPS for this particular workload. Again, this is just one sample. I didn't do it, multiple times to make sure my sample was, accurate. But average was 15 IOPS. The peak, of course, was close to 1,000. So those SSDs are quite performant. That's peak, right? It's not sustained peak. Everybody knows that peak, one-time burst, depends on the transfer size, depends on a bunch of other things. But the one-time peak was able to hit 1,000 IOPS based on perfmon. And if you do a Jim Moyle iometer, 4K, 80%, 20%, all that kind of stuff, against these ISSDs, and you do it at scale, which I did, and you do it not just peak, but sustained peak, they're able to consistently deliver over 400 IOPS at a larger work set. So if somebody held a gun to my head and said, tell me exactly how many IOPS you can get from this, I would base it off of what Jim has well documented on his blog and what they use, and I'd say based on that work set we can provide at least 400 IOPS. So the SSDs were the surprising factor when I actually got it tuned up. Anybody want to talk about that for a bit? Because that's probably, that and the GPU are my 2 favorite things about this particular scenario. So, based on that number, I mean, if you take 400, if I'm going to guarantee 400 per node in the cartridge, and you work that out to 180, don't correct my algebra this time, but I'm pretty sure it's over 60,000 IOPS, probably closer to 80,000. I didn't do exactly the math on that, but 200 and 400 is 80,000. So somewhere in between 60 and 80. And Carl can do the math on that. So in a chassis, in a fully populated chassis for 180 users, you have at least 60,000 IOPS. I don't know many other solutions that for 180 users are saying, yep, that's the performance that you're going to get. So this is pretty good. I used GPU-Z, which is a free utility that you can go grab that actually does a logging to a log file of GPU utilization over time. And this was using the standard VDA, which again, they wrote a hotfix that tells the VDA to offload to the API if it does Windows Media decoding or anything like that. And the standard VDA, not even HDX3D Pro, was averaging about 8% over that 48-minute period of time, and the peak was 25%. So the GPU makes a big difference in this scenario. And as we know, when a GPU is not present, it's going to fail back to software GPU or CPU, which is going to be higher in terms of CPU. And that's also one of the ways that I've explained why the CPU usage was only about 11%, because in this login VSI workload, they're actually doing quite a bit of media and doing a bunch of HTML stuff that can create GPU workload. The average memory usage for the GPU on this particular test was 181 megs, and the peak was 250. And again, it's dedicated 512 megs of RAM per node. So that's it. If anybody wants to see a demo, I can pull that up. Any questions? So this was this was the first release of Moonshot targeted at hosted desktops. The M700 cartridge, if you see that in the media, is the one that all this slide deck and stuff was based on. Again, they come in 32 and 64 gig options, so if you want to do dedicated desktops, you can do that. Their future, like the roadmap, I know this is recording, but I'll give you guys privy information. There will be a two-way system in the future that's basically 2 nodes per cartridge, higher end nodes per cartridge. During the reveal on Wednesday, there was the big Intel announcement that is based on the Iris Pro. That is Intel's take on this. So AMD is going to come out with a two-way system that's 2 nodes on 1 cartridge. Intel is going to have the Iris Pro, which is going to be a higher end, or like a Xeon prop. And so what I believe is that this one that I've been playing around with for almost 9 months is really the proof of concept for the market. It's to test it, to see, is this a concept that could work? And based on that success or failure, they'll develop additional form factors that can better suit the user's needs. The most important part between all of us in this room is that I work with a lot of smart people, and it's always fun not being the smartest guy in the room. And we can build some very elegant, very sophisticated, very well-designed systems. But when they turn over to operations, or when the customer's environment is less managed than it should be, it doesn't matter how much engineering effort you put in on the front end, it can go to pop. And so what this solution, in my opinion, does is give a better, consistent user experience from day one to 3 years from then. And then you basically treat it like PCs. If you have a 3-year refresh on your PCs, you have a 3-year refresh on this. If you have a 5-year refresh, you have a 5-year refresh. And at that point, you would then reevaluate the user's needs to see if this is still a good fit, or if you should move them up into the next cartridge or to the next form factor. But without the sharing of resources, in my opinion, the selling point to this is a consistent user experience from day one until the end, right? So that's my spiel. I don't work for HP or Citrix or anyone else.
I think the lifetime of the actual chassis is longer than the cartridges.
I think it is, yeah. I don't know exactly what it is. If anybody wants to know, that's great, but there's more. Like, what price is this at? They do have some public information, so this isn't privy customer information. Obviously, discounts may vary, but a fully populated chassis with the switches, with the uplinks, with 45 cartridges for 180 users. They had some published information that it's about $130,000, and the math on that works out to about $800 per user. That's list price without discounts. So if you have a larger environment, you can go to HP and say, look, we want to deploy 5,000 seats on this, or we want to deploy 2,000 seats on this, whatever you want to do, and they'll give you discounts based on your quantities. But the stance from HP at this time, which they're going to change in their future because they have to, is that they're only supporting a single cartridge per chassis. So if you have a need for this and web workloads and high graphics, something other workloads, you buy a different chassis for each of those. So I would imagine that that would correlate to the lifespan, because 3 years from now when you need to go refresh these cartridges, there's probably going to be a newer chassis that has different uplinks and different interconnects to support that newer cartridge. Part of the reason is because internally some of the connectors are different. So the first one that they released had a 45 gig switch because the first Moonshot, the Atom that was available, was a single node per cartridge, right? So 45, you just need 45 ports. This is 180. So if you took one of these chassis and you threw one of the Atom or Avaton cartridges in here, it would work. It would just pick the first NIC off of the 4 NIC for 180, but you'd be overbuying, right? You would want to buy switches that were 45 gig switches if you're going to use a single node per cartridge. These are more expensive, so a couple thoughts there. Any other questions? No?
Thanks for filling in at the last minute.
Yeah, thanks.